In this short video, we're going to talk about which strategy is the most efficient strategy to use and when. Because we have lots of strategies to use to solve subtraction problems, but which strategy is the best for a given problem? So we're going to talk about counting on or counting back and which strategy works. So in the first problem we have 10 subtract 9. If we try the counting on strategy, we will start at 9 and count to 10. So we just had one hop, so we know that 10 subtract 9 is 1. If we try the counting back strategy, we would start at 10 and count back 9 hops. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. While we still end up at 1, and the difference is still 1, the counting on strategy was more efficient, which is a faster way to solve the problem. So this first example, we would use the counting on strategy. Let's look at the second example. We have 9 subtract 1. If we use the counting on strategy, we would start at 1 and count on until we get to 9. 1, 2, 3, 4, 5, 6, 7, 8. We counted 1, 2, 3, 4, 5, 6, 7, 8 hops to get from 1 to 9. So the difference, or the answer, is 8. But what happens if we use the counting back strategy? We start at 9 and count back one hop, and we end up at 8. Either way, our differences are 8, but it looks like for this problem, because we were only subtracting 1, which is not very many hops, the best strategy is counting back. So 9 subtract 1 is 8. Let's look at the next problem. The next problem says 8 minus 5. So if we're going to do the counting on strategy, we start with our 5, and we count on until we get to 8. 1, 2, 3 hops. 1, 2, 3 hops leaves us at 8. So our difference is 3. That's the difference, or the number of hops it takes to get from 5 to 8. But what happens if we try our counting back strategy? We start at 8, and we count back 5 hops. 1, 2, 3, 4, 5 hops. 1, 2, 3, 4, 5 hops. And we end at the number 3. Our difference of 3 is the same as when we counted on, but it looks like the counting on strategy worked a little more efficiently here. So the difference is 3 and counting on. It takes fewer hops to get to the answer, so that's why I would choose the counting on strategy there. Let's look at 8 subtract 6. If we start at 8 and we hop back or count back 6, that would be 8. Start at 8, 1, 2, 3, 4, 5, 6 hops back. We have a difference of 2. If we start at 6 and count until we get to 8, 1, 2, we still have a difference of 2. Our answer stays the same, but it looks like in this instance, counting on was more efficient because we were subtracting a greater number. 6 is much more than 1. Let's try the next problem. 7 subtract 4. We have 7, and we're subtracting 4, so 4 hops back. 1, 2, 3, 4, and we end up at 3. Or we can start at 4 and go 1, 2, 3. So which one's the most efficient strategy? Here we have 1, 2, 3, 4 hops. Here we have 1, 2, 3 hops. So it looks like counting on would be a more efficient strategy to get to our answer of 3. Let's try this last one. We have 6 minus 3. 6 is where we start and we subtract 3, or it's 3 hops back. 1, 2, 3. 1, 2, 3 hops back, and our difference is 3. Or we start at the number 3, which is what we were subtracting, and count to 6. 1, 2, 3. We still have 3 hops. So on this problem, you have 3 hops counting on, you have 3 hops counting back. So which strategy would you choose? In this instance, it's just a matter of preference. The difference is 3, whether you choose counting on or counting back. So the important thing to remember is you have strategies that work. You just need to be smart about when to use counting on or counting back. It's your choice.